Good morning, everyone. Slightly delayed. I won't make any attempt to cut short this session. So we'll see how we can manage, and you'll still get some enough time for your tea and coffee break. The issues still continue. क्या वो कैमरा नहीं चल रहा? बंद करके फिर दोबारा करूँ? So the golden rule to get something working, if it's not working, is to restart this system. Like that usually always works out. Sorry. Post shut now. Are we good to go? Everything fine? Yes, students. They've not joined. They've not rejoined. Is the link? Is this link the same? Okay. So maybe we'll just wait for a couple of more minutes to actually start the session. But before that, do you see that how much thankful we should be to the teaching assistants or the teaching assistants, to the staff and the folks and the students who are helping there? So can we just thank all of these people? They're not even listening. Yes. This is for all of you. Thank you. So it's not easy to be in a pressure situation like this. So they're unnecessarily feeling guilty. It's not their problem. It's not their mistake, actually. Such systems, sophisticated systems, are generally hard to get rolling. Should I start or can I do something else? Shruti, should I start? System? Please. Okay. But can someone else see if others are online? So why don't you call Anirban and just talk to Anirban if he can see the issue. So till these people are figuring out this, let me actually show you. So you've been seeing now, you've seen the code in JAX and similar frameworks. I thought that I'll show you. So there was a question yesterday, day before yesterday, that we use ReLU a lot, right, for neural networks as the activation function. But the ReLU doesn't have a gradient defined at x equal to 0, at z equal to 0, right? So let's look at how we find the gradients in modern frameworks. So I'm using JAX here, import JAX, I a function fx. In this case, the function is just the ReLU function. So jax.nn.ReLU of x. As you can see, f of 0 is 0. You'd expect that. So the function f of x is max of 0 or x, right? The maximum between 0 and x. F of minus 1, as you'd expect, is 0. I can write the gradient of a function. I can find out the gradient of a function writing it like this: df equal to jax.grad of f. I have to pass in the function. I have to also give in the arguments with respect to which I want to calculate the gradient. In this case, the argument is a single argument, f of x, right? And then if I write df of 2, you'd expect to see 1, because anything which is positive will have gradient 1. Anything which is negative will have gradient 0. The only question is, what is the gradient at 0? And in this case, the gradient at 0 is defined to be 0, right? So software frameworks can overcome the mathematical limitations where you explicitly can mention that gradient at x equal to 0 is 0, right? Otherwise, it's undefined because it's not a continuous function. Sorry, it's a sharp point there. So I thought that this would be interesting for you to see that it's a matter of just a couple of minutes for us to be able to write such functions. Any other thing you want me to show? Sorry. For negative values, you get 0. The gradient for the negative values is 0. Yes. Yes. So it won't reach 0, but here I've specifically given it to be 0. So it may be in machine precision, it may be 1e minus 12 or something minus 1e minus 12. So it may be very, very small number, about close to 0, but it may not be the exact same number. So once you get the hold of writing such cost functions, right? So write the function and find the gradient with respect to it. You have solved the problem. So we can in fact take another demo also, right? So let's say G, let's write G of X, comma Y. Return X square plus Y square. And let's write grad of G partial with respect to X is equal to Jax dot grad of G. And because the first argument will directly be picked up. And if I have to write, let me actually just see. So if I write question mark in the IPython shell, I get the function definition, which is useful. So it says that I can give the argnums, which is a sequence of integers. Right. So if I want to find out the gradient with respect to y, I have to write something like this. I can directly write actually with respect to the first argument only, right? Now I've got the gradient function. So what do you think is grad gx at x equal to 2 and y equal to 2? What is grad gx? So firstly, grad gx is a function. You can see that. Right? It's a function which accepts the same argument as the original function g, right? Because it's just the gradient of a function. Right? So what do you think is grad gx at x equal to 2 and y equal to 2? 4. Right? We get the correct answer. Actually, let me modify the g function a little. Let me make it x square plus y cube. And now if I run it at x equal to 2.0 and y equal to 2.0, what answer do you expect? Same answer. Right? But if I had to do with respect to, okay, I have to actually find out the gradient with respect to y again. Okay, now what do you expect if I find the gradient with respect to y? So the gradient with respect to y, the function of y is y cube here. The gradient with respect to y is 3y squared at y is equal to 2, that is 3 into 4 is 12. So you don't need to write any complicated functions now. You can just define your cost function or the function with respect to which you want to find the gradient, and you're done. Any luck? Almost done. Okay. So we can similarly write a function for linear regression also, right? So if we had to think in terms of the cost function for linear regression, that's just y minus y hat, right? For each of the point, and then square it, and then you can just find out the, like, you can just find out the norm, second norm of y minus y hat, L2 norm. Right? That's how we can write it. Anything, any other thing you want me to show? So we also saw this nice demo yesterday day before yesterday on ridge regression. So I was using a service called, what is it called? Let me just see. Hugging Face demo. So how much time do you think it will take me to write a code to generate a figure like this? We saw this figure earlier. As we vary the degree, we see that the unregularized function, this is a linear regression, it becomes very complex as you'd expect. But the regularized version, which is the ridge regression, and as we have a high degree of regularization, it's relatively a smooth curve, right? How much time do you think it will take us to write such a UI? And you find this UI useful? Let me ask that. Yes. So how much time do you think it will take us to write something like this? Once you know the machine learning part of it. Because this is a, so if you had to do this in the older days, you would have to write some JavaScript, right? Because the front end is a HTML page. You would have a JavaScript code running, which figures out that what is the value of the slider, right? You send this response, these slider values back to the server, which computes